So here I'm going to do another equation of a problem of a line in standard form. We're going to graph it. Again, we're going to do it both ways because again, I don't ever want you to think that I don't ever want you guys to think problem A, solve it in technique in this one way, boom, done. Of course, it's true that you may develop a preference for some of these techniques, and I don't discourage you from using your favorite technique all the time. But I want you to have all these techniques at your disposal so you guys can be more and more confident over time. So our first technique again is going to be to find the intercepts. Okay. So here, the nice thing about finding the intercepts is you're setting one of the variables to 0. That makes the calculations very easy. Okay. So if I want to find the X-intercept, right? I remember to myself, okay, for my X-intercept, that's the point on the X-axis where the line is going to cross. I ask myself, okay, what is true about every point on the X-axis? Aha, Y equals 0. So I set Y equal to 0, and I solve for X. This might be something you might want to put on an index card. To find the X-intercept of a function, set Y equal to 0, solve for X. Right? Okay. Now in this case, if I set Y equal to 0, this expression becomes 2x minus 5 times 0 equals 10. Okay, 5 times 0 is 0. So this left-hand side simplifies to 2x. Okay. My right-hand side stays 10. I divide both sides by 2. And I get x is equal to 5. Okay. Okay. So my X-intercept will therefore be the point 5, 0. Okay. 5.
Sorry, I don't know how to help with that yet.
Okay. So my X-intercept will be the point 5, 0. 5, because that's the X value we got when we solved the equation when we plugged in Y equals 0. The X is 5, the Y is 0. Okay. So now what we're going to do is we're going to find the Y-intercept. Okay. So in order to do so, right, what do we know about every point on the y-axis? Every point on the y-axis has x coordinate 0. So to find the y-intercept of a function, I set x equal to 0, and I solve for y. Okay. Okay. So now if I set x equal to 0, this expression, or this equation rather, becomes 2 times 0 minus 5y equals 10. Okay. Okay. 2 times 0 is 0. So this equation becomes negative 5y equals 10. I want you guys to observe something. This 2 times 0 minus 5y, it doesn't become 5y. It stays negative, okay? That is a key point, okay? Now here, I divide by negative 5 to get the y by itself. I divide by negative 5 to get the y by itself. And I say, aha, my y is going to be negative 2. So if I set x equal to 0, comma, my y is equal to negative 2. Okay? Okay. So we are now prepared to solve this equation. We're now prepared to graph this linear function. So first I'm going to look at what I need my points to be. I need to have a negative y, positive x. So maybe instead of drawing the whole thing, what I'm going to do is I'm going to focus on drawing the bottom part like this. This is my x-axis up here. This is my y-axis. This is maybe -1. This is maybe -2. Then my x's, I have 1, 2, 3, 4, 5. I can plot that point, 5, 0 here. I can plot this point, 0, -2 here, right? And then I can draw my line through these 2 points. Let me see if I can get that here. By the way, this is not a dotted line, but I'm just trying to jump so that like I can avoid the 2 so that the graph will look will look as nice as possible. Okay, so this then is the equation of our line through these 2 points. I want you to observe, whenever you see a graph like this, I want you to think, okay, I got the y-intercept, I know the slope now. Looking at how it tilts that way, I can see it's a positive slope, right? And in fact, it's a rise of 2 and a run of, let me see here, 1, 2, and then a run, 1, 2, 3, 4, 5. So I can see that the slope is equal to 2/5. I can see that the y-intercept, which we'll just write y-int for slope, is -2. So if I wanted to, without solving this equation for y, I could just say, y equals 2/5 x minus 2 as my slope-intercept form, okay? And then I could use that to like fill out like some table of values in case I want the value of this function at some intermediate point or at some point way out here. Let's say, what is the value of this line for x equals -100, for x equals to 100, in case it has some practical value, like some cost or like some measurement, But from our perspective, I just want you to be able to like do this kind of thing, right? To look at a graph of a line, and if you know some of the points, to get the slope from looking at the rise run, whether the slope is positive, negative, Anyway, so now let's continue, okay? So we got this information over here, but let's get rid of it for now temporarily. And like I said, I wanna emphasize, I could find other points on the line just using this. I could say, if I plug in x equals, so let me do that here as an example. Okay. So I'm gonna slightly deviate because I don't need to plot any more points to graph this line, but maybe I want some more points for some other reason, right? So like, what point on the graph occurs if x equals 1? So for example, if x equals 1, I can use my equation to find out what point is on the line. I plug in for 1. 2 times 1 minus 5 times y equals 10. What's 2 times 1? It's 2. So 2 minus 5y equals 10. I subtract 2 from both sides. And I get -5y equals 8. When I divide, I'm going to get y is going to be -8/5. Okay? So I can see that the point, if I'm going to plot it here for us, okay? Wait. Oh yeah, x equals 1. That would be here. So this point, now we know, is actually 1 comma and -8/5. So that's going to be slightly above this, right? It's going to be slightly above the -2 because it's not -2. -2 would be -10/5. So it's just above it, right? And we can continue. We could find out what the value is for x equals 2 if we wanted to, and so on, just by plugging into this equation and solving for whatever value we want. Okay. But so now we're gonna leave this behind us, and we're gonna proceed on to technique 2 to solve this equation for y, to try to find out what the slope-intercept form is directly, and then to plot the intercept and then to use the intercept and the slope to plot the graph itself. Okay, So let's say I look at this. Okay. I'm going to copy it here. Okay. 2x minus 5y is equal to 10. So then what I'm going to do is I'm going to subtract the 2x to the other side. Minus 2x minus 2x. And I get that negative 5y is equal to negative 2x plus 10. Okay? Then I'm going to divide both sides by negative 5 to get the y by itself. The negative 5's cancel here, and I'm left with y equals a negative divided by a negative is a positive. So this will be positive 2 over 5 x. Then a positive, that plus 10 divided by negative 5 will be a minus 2. And we can see that this is entirely consistent with what we have here. First of all, we can see that the y-intercept of our graph is negative, the y-intercept of our slope-intercept form is negative 2. That is indeed what our graph's y-intercept was, negative 2, or is. We can see that the slope is 2/5. So how do we interpret this positive slope? The slope is positive, so we're going to go up 2, 5 to the right. Up 2, 5 to the right. So if I start at negative 2, 1, 2, up 2, and then 5 to the right, 1, 2, 3, 4, 5. Indeed, we arrive at the point that we graphed there. And there you go, technique 2. And now we will proceed to another problem. I hope you all are enjoying this, and yes, we're going to continue.